Okay, for this problem, whenever you're seeing coordinates, you should probably graph them. That's going to be the easiest way to do this problem. And we're trying to figure out if it's scaling, which means every side's a different length. Isosceles means two are the same, one's different. Equilateral means they're all the same. Right, we're probably going to have to look at slopes to figure that out, and then same thing for equiangular. But I mean, if it's equilateral, it would automatically be equiangular. First, let's figure out the length of each side. We can use the distance formula, which is basically just making right triangles. So to figure out the distance from A to C, you can do this. So that would be 1, 2, 3, 4, 5 units. 1, 2, 3, 4, 5, 6, 7 units. The distance here is 5 squared plus 7 squared. That's 25 plus 49. I want the calculator here. Calc. 25 plus 49 equals 74. So the length here is the square root of 74. It's going to be irrational, so I'm just going to leave it in a radical for now. Square root of 74. I'll do the same thing for A and B. That's 5 units. That's 4 units. So that's 25 plus 16. 25 plus 16 gives us 41. So the length of AB is the square root of 41, which is also irrational, so I'm not going to write it. So all that really matters to us is that these are different numbers. So it's definitely not equilateral. We already know that for sure. And now I need to check the length from B to C. This is, I'm going to draw this one, 1, 2, 3 units. This way is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units. 3 squared plus 10 squared, that is 9 plus 100, which you could probably do mentally, but 9 plus 100 equals 109, so this side of the triangle is the square root of 109. So even without making these into irrational decimals, we can tell that they're all different, different lengths. So it is definitely scaling. It is not isosceles, because isosceles means two are the same. It's not equilateral, because that would mean all are the same. To figure out if it's right, we're probably going to have to look at the slope, and then we'll be done with this. Since I made these triangles, I actually already have what I need for slope. To go from A to C, we can do rise over run, so the slope here is 5/7. If it's a right triangle, then one of these other lines is going to have a perpendicular slope. This one is 5/4. Oh, wait. 5/4 is the slope here. Negative 5/7 is this slope. And then over here we have rise of 10, run of 3. So that's negative 10 thirds for the slope. None of these slopes are perpendicular, which means there are no right angles here. Just as a reminder, a perpendicular slope would be like, compared to this, it would be positive 3/10. So no perpendicular slopes. It's not a right triangle, and it's not equiangular either, because all these angles are just random numbers that add up to 180. So that is the answer.